Hello everyone, in this video we'll be solving problem 3446, sort matrix by diagonals. The problem statement is, we are given an n by n square matrix of integers grid. We need to update the grid where the bottom left triangle is in the non-decreasing order while the top right is non-decreasing order. If you look at example number 1, the main diagonal, that is the centralmost one, contains 1, 8 and 6. As it is part of the bottom left triangle, we need to apply the non-increasing order. So we need to sort it in a descending order in other ways. The updated sequence is 8, 6 and 1, which is reflected in the updated grid. The same applies to the remaining diagonals in the grid. The problem statement is very straightforward and easy to understand, and so is the solution. So let's switch to whiteboard and discuss how we can solve this problem. I'll be using the same example that is given in the problem statement. If we closely observe this 3 by 3 grid, there are a total of 5 diagonals. The simplest way to break this down is to look at the diagonals that start from the first row and then first column. The area covered in the first row will be considered as the top right triangle, while the area covered by the column will be the bottom left. It is already given in the problem statement that the main diagonal should be considered in the bottom left triangle. As there are two triangles we need to process, we'll start with two separate for loops, one to iterate through the top right triangle and the other one to iterate through the bottom left. For the top right, we'll keep the row as constant while the column will be variable. To get the elements in the corresponding grid, we'll increment row and column by 1 until we are not going out of bounds. During the iteration, we'll save the values in the diagonal in a separate collection, after which we can sort it and then save the updated sequence back into the grid. As the elements we iterate through a corresponding grid do not intersect with any other diagonals, it is safe to save the updated values back into the grid at the very same time. This will help improve our space complexity. After processing the elements in the top right triangle, now we can process the bottom left triangle by keeping the column as constant and the row will be variable. The logic is identical to the previous approach. The only difference is the sorting order. The first triangle is to be sorted in the non-decreasing order, while the second half needs to be sorted in non-increasing order. Let's do a short dry run with row is equal to 0 and column is equal to 0. The element value is 1. Now if we increment both row and column at the same time, next elements are 8 and 6. Now that we have all of the elements, we can apply the sorting logic on it to update the sequence and save it back into the grid. To save the values, we can start another for loop with the default values, that is row 0 and column 0, run the loop and use the updated value to be saved back into the grid. For each diagonal, we are using extra memory to store the original values in the diagonal and then sort it before we can save the updated sequence back. This is going to be useful when we are going to calculate the space complexity of our solution. For the next run, we'll increment the column value to 1 and look at the next two elements and update its sequence accordingly. The same process will be repeated for the bottom left diagonal. Here the difference would be the column is constant while the row is going to be variable. In this solution, our time complexity is O of n square into log n. N square because we are iterating through all of the elements in the given grid, and log n is because we are sorting the elements in a diagonal in ascending or descending order. And the space complexity is O of n, as we are using some sort of a collection to record the original values in each diagonal before we can sort it. As the longest diagonal is the middle diagonal, which will not contain more than n elements, the space complexity will be O of n in the worst case scenario. I hope you are able to understand the explanation. Let me show you how we can implement this using C#. In this C# implementation, I have two for loops. First one is to iterate through the upper right triangle, while the second one is to iterate through the bottom left. Inside the for loop, I have initialized a variable diagonal which is of type list of integer, and I will be saving all of the elements in a particular diagonal in that collection. After saving the values in the collection, I am sorting it in the ascending order because we are working with the upper right triangle, and then saving it back into the grid. I am repeating the same operation in the second for loop except for one difference. All of the elements that we extract from the diagonal are being sorted in the descending order by applying the reverse operation on the array. Once the two for loops are complete, I am returning grid as the output. This code, when submitted on LeetCode, beats 59% of the submissions in terms of runtime and nearly 73% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.